Very good morning, students. Welcome to our second class of matrices. Yesterday, we have started a chapter matrices. We have discussed some concept in this matrices chapter. Now, we'll continue today some more topics in this matrix. Here, we'll start with this symmetric matrix. Here, a matrix is called a symmetric matrix. Here, a square matrix A is called a symmetric matrix if a transpose of the matrix is equal to the square matrix itself. A transpose is equal to A. Already yesterday we have discussed what is transpose of the matrix. Transpose of the matrix means we are interchanging rows into columns of the given matrix. The resulting matrix is a square matrix. Even if interchanging the rows into columns, the resulting matrix is same as the given matrix, then the square matrix is called a symmetric matrix. For example, we have A is equal to 1 to 2 1. If we write A dash, A transpose, if we write, the resulting is 1 to 2 1 only. So this kind of matrix is called symmetric matrix. Here A transpose is equal to A matrix, then the matrix is called symmetric matrix. Similarly, next is a skew symmetric matrix. Skew symmetric matrix. A square matrix A is called skew symmetric matrix if A transpose is equal to minus A. If we transpose this matrix A, then we should get minus A. For example, here A is equal to 0, 2 and minus 2 comma 0. If we write it transpose, A transpose become row I have changed into column. First row I have written as a column 0, 2 and second row minus 2, 0. This become minus 2, 0 second column. And on taking minus common from this matrix, if we take minus common from this matrix, this becomes 0, 2, minus 2, 0. Means this is same as the given matrix A. A transpose is equal to matrix A minus matrix A, then the matrix is called skew symmetric matrix. Here, by observing the matrix directly, we can say or we can identify whether the given matrix is symmetric or skew symmetric. That method I will tell you. This in this example, diagonal element. Diagonal means left top to right bottom. This is called principal diagonal also. Here, with respect to this diagonal element, right side or upper and lower elements are same. देखिए diagonal के right side या upper side में या lower side में उस तरफ भी 2 है और इस तरफ भी 2 है. अगर ऐसा है तो ऐसे मैट्रिक्स को हम क्या बोलेंगे? सिमेट्रिक मैट्रिक्स. ओके. एंड स्क्यू सिमेट्रिक मैट्रिक्स. स्क्यू सिमेट्रिक मैट्रिक्स का स्पेशलिटी ये है कि ये डायगोनल एलिमेंट जो होते हैं ऑलवेज 0 0. स्क्यू सिमेट्रिक मैट्रिक्स के डायगोनल एलिमेंट क्या रहेंगे? 0 0. और इस डायगोनल के अपर एंड लोअर एलिमेंट सेम रहेंगे बट अपोजिट साइन. अगर अपर साइड +2 है तो लोअर साइड क्या रहेगा? -2. अगर अपर साइड -2 है तो लोअर साइड रहेगा +2. So such kind of matrices are called symmetric and skew symmetric. Symmetric, A transpose is equal to A matrix. Skew symmetric, A transpose is equal to minus A matrix. Okay. The next, properties. Some properties, important points on this. What is that? Symmetric and skew symmetric matrices. So one thing you remember, if A is a square matrix, if A is a square matrix and A transpose A power t is its transpose of the matrix, then A plus A dash is always a symmetric matrix. A plus A dash क्या होता है? Symmetric matrix होता है. And A minus A dash is always skew symmetric matrix. Okay. If we have a square matrix A and the transpose matrix is A dash, then always A plus A dash is symmetric and always A minus A dash is skew symmetric matrix. Then next point is every square matrix This is the first point. Now the second point is every square matrix can be expressed as a sum of symmetric and skew symmetric matrix, and it is uniquely expressed. Okay, every square matrix A can be expressed as a uniquely the sum of symmetric and skew symmetric matrix. And this can be expressed as a, here A is equal to 1 by 2 A plus A dash plus 1 by 2 A minus A dash. What is A plus A dash? A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix, and between these two what we have symbol plus, means sum of symmetric and skew symmetric matrix. Next, if A and B are symmetric matrices, if we have A and B are symmetric matrices, then AB is symmetric. A into B is also सिमेट्रिक रहेगा. अगर A और B दो स्क्वायर मैट्रिसेस है और वो दोनों मैट्रिक्स सिमेट्रिक है, तो A इंटू बी मैट्रिक्स क्या रहेगा? A इंटू बी इज आल्सो सिमेट्रिक मैट्रिक्स. एंड AB इज इक्वल टू BA, AB इज इक्वल टू BA पॉसिबल होगा. Already we know in multiplication of matrices AB equal to BA is always not possible. It is not commutative. But this is a special case. Here the matrix A and B are symmetric matrices. That's why AB is equal to BA is possible here. Means A and B are commute. Commute means commutative. A and B matrices are commutative. When they are commutative here, if the matrix A and B are symmetric matrices. And one more point is given here, B transpose A into B is symmetric or skew symmetric. यहाँ पे A and B दो स्क्वायर मैट्रिसेस हैं, तो B डैश इंटू ए बी इज सिमेट्रिक या स्क्यू सिमेट्रिक और स्क्यू सिमेट्रिक, यानी कि ये मैट्रिक्स तीन मैट्रिसेस का मल्टीप्लिकेशन मैट्रिक्स है. ये B डैश A एंड B तीनों मैट्रिक्स का जो मल्टीप्लिकेटिंग रिजल्ट है वो सिमेट्रिक भी हो सकता है और स्क्यू सिमेट्रिक भी हो सकता है. दैट इज डिपेंडिंग अपॉन द मैट्रिक्स. ये वो मैट्रिक्स ए पे डिपेंड रहेगा. अब समझिए मैट्रिक्स ए सिमेट्रिक है. अगर मैट्रिक्स ए सिमेट्रिक है तो फिर ये वाला बी डैश ए भी सिमेट्रिक रहेगा. अब समझो ए मैट्रिक्स क्या है? स्क्यू सिमेट्रिक है. Okay, A is a skew symmetric matrix, then B dash AB is also skew symmetric. Here A B dash AB is symmetric or skew symmetric in correspondence if A is symmetric or skew symmetric. अगर A symmetric, B dash AB symmetric. A skew symmetric, तो B dash AB skew symmetric matrix. All integral powers of symmetric matrix are symmetric. यानी कि अगर A मैट्रिक्स सिमेट्रिक मैट्रिक्स है, A स्क्वायर भी सिमेट्रिक, A क्यूब भी सिमेट्रिक, A पावर 4 सिमेट्रिक. ये जो पावर्स है ना, पावर्स क्या है? पॉजिटिव पावर्स है. पॉजिटिव पावर्स, अगर उनके पावर्स पॉजिटिव है तो फिर रिजल्टिंग क्या रहेगा बेटा? वो भी सिमेट्रिक मैट्रिक्स रहेगा. द नेक्स्ट, पॉजिटिव ऑड इंटीग्रल पावर्स ऑफ स्क्यू सिमेट्रिक मैट्रिक्स आर स्क्यू सिमेट्रिक एंड पॉजिटिव इवन इंटीग्रल पावर्स ऑफ स्क्यू सिमेट्रिक मैट्रिक्स आर सिमेट्रिक. अब यहाँ ये वाला जो पॉइंट है दैट इज बेस्ड ऑन द सिमेट्रिक मैट्रिक्स. सिमेट्रिक मैट्रिक्स का पावर इवन रहने दो, ऑड रहने दो, ऑन एक्सपैंडिंग रिजल्टिंग इज ऑलवेज सिमेट्रिक. लेकिन स्क्यू सिमेट्रिक ऐसा नहीं है. ओके, अगर स्क्यू सिमेट्रिक को हम पावर ले रहे, पावर स्क्वायर, क्यूब, पावर 4, पावर 5 ऐसे ले रहे, एंड द पावर इज, व्हाट इज पावर हियर? पावर इज ऑड इंटीग्रल पावर. यानी कि A is a skew symmetric matrix. तो A power 1 skew symmetric, A power 3 skew symmetric, A power 5 skew symmetric, A power 7 skew symmetric. अगर पावर ऑड नंबर है तो वो skew symmetric ही रहेगा. अगर पावर इवन है, पावर इवन यानी कि a square, a power 4, a power 6, a power 8. अगर power even number है, then the resulting is symmetric matrix. The resulting is a symmetric matrix. ओके तो यहाँ पे कुछ हम लोग प्रॉब्लम्स डिस्कस करेंगे बेस्ड ऑन दिस मैट्रिसेस टॉपिक. Okay, we will discuss problems on this matrix chapter. The first question, find the value of x if the product of three matrices is equals to 0. यहाँ three matrices है, ये एक रो मैट्रिक्स है, ये 3 into 3 मैट्रिक्स है और ये column matrix है. On multiplying these three matrices, the resulting value is 0. Then what is the value of x? So we are finding the value of x here. सही. Let us solve this problem. Here we have a first matrix 1 into x into 1 and this is multiplied with 1 3 2 2 5 1 15 3 2 multiplied to 3. These two matrices. First I am taking the first two matrices and multiplying. Later the resulting multiplying with the third matrix. Okay na? So let us multiply these two matrices. The row is multiplied with the column here. Okay. Row is multiplied with the column. 1 into 1, 1 plus x into 2, 2x. 1 into 15 plus 15. This is the first row, first column elements. Next, first row is multiplied with the second column. 1 into 3 is 3. X into 5 is 5. And 1 into 3 is plus 3. Next, the row is multiplied with the third column. 1 into 2 is 2. And x into 1 is x. And 1 into 2 is 2. We multiplied the first row, only one row we have. This row with all the three columns. With all the three columns we multiplied. Let us simplify this. This become 1 plus 1 is 2. No, 1 plus 15. This is 1 plus 15 is 16 plus 2x. And the second element 3 plus 3 6, 6 plus 5 11. And the third element 2 plus 2 4, 4 plus x. This is the resulting of the multiplication of first two matrices. Let us multiply this resulting with the column matrix, that is 1, 2 and x. And is given that this product is equal to 0. We have only one row and one column. 16 plus 2x into 1, that is 16 plus 2x, plus 11 into 2, 22, 22, plus 4 plus x into x. 4 plus x into x into 4 is 4x. X into x is x square. And this resulting is given, it is equal to 0. Or directly we can take here, this is equal to the 0. This element is equal to 0 we can consider. Now this is a quadratic equation and it is expressed as x square. 4x plus 2x is 6x. And 16 plus 22 is 28, 38. That is plus 38 equals to 0. 38. 11 2 is 22. 4x plus 2x. Okay. X square plus 6x plus 38 equals to 0. X. This is actually, this is not a 5, it is 5x. 5x. Then this become This becomes 6 plus 5x. 6 plus 5x is multiplied with a 2. So actually here we done a mistake that I'm rectifying here. Here x I have not multiplied. That's why we're getting this wrong. This matrix is multiplied with this column. 16 plus 2x into 1 is 16 plus 2x, and 6 2s is 12, 5x 2s 10x, and 4 into x is 4x, and x into x is x square, and this is equal to 0. This is what a quadratic equation. On solving this quadratic equation, we'll get the value of x. Let us write it is in standard form. The first term is x square. Next term 4x, 10x, 14x. 14x plus 2x, it is 16x, plus 16x, and plus 16 plus 12. 16 plus 12 is 38 is equals to 0. 38? No, 28. That is 28 is equals to 0. Now we are factorizing this quadratic equation by splitting the middle term. The middle term we are splitting x square, the 16x we are splitting as a 14x plus 2x plus 28 equals to 0. As you know, we will multiply the first term with the last term, we'll get 28x square. We supposed to select the two numbers whose multiplication is 28x square and addition or subtraction is 16x. That become 14 2s are 28 and 14x 2x is 28x square, and their sum is the middle term, that is 16x. In the first two term x is common, remaining x plus 14, and in the remaining two term 2 is common, remaining x plus 14 equal to 0. In this factorization, if we are getting both brackets are same, then our factorization is correct. Then outside the bracket we have x plus 2, inside the bracket we have x plus 14 equal to 0. Either x plus 2 equal to 0 or x plus 14 equal to 0. X equal to minus 2 and x equal to minus 14. This is our answer. So let us check this option. X equal to minus 2, x equal to minus 4. X equal to minus 2, x equal to minus 4. This is A, this is B, this is C, and last one is D. Third option is correct. Minus 2, minus 14. The third option is correct in this. Okay, let us move to the next problem. Here is given the matrix A is equal to 1 1 0 1. It is 2 into 2 matrix, and we have to check A power n is equal to which matrix, whether first, second, third or fourth, that we have to find. So this can be predicted, not answered here directly. It can be predicted by multiplying or by finding a square and a cube matrices. By comparing matrix A square and a cube, we can predict which option is correct here. We have given matrix A. Let us find a square here. A square is matrix A into A. That is equal to 1 0, no, not 1 0. This is 1 1 0 1 and multiplied with the same matrix 1 1 0 1. And you know the multiplication of matrix, the row of the first matrix is multiplied with the column of the second matrix. Let us multiply the first row, first column. 1 into 1 is 1, and 1 into 0 is 0, plus 0. Next, first row, second column. 1 into 1 is 1, and 1 into 1 is 1. Next, first row, first column over, first row, second column is over. Columns are over. Next, start with the second row. Second row, first column. 0 1s are 0 and 1 zeros are 0. Next, second row, second column. 0 1s are 0 and 1 1s are 1. the resulting we are getting a matrix 1 2 0 1, 1 2 0 and a 1. Let us find the matrix A cube. Matrix A cube find करेंगे हम. Matrix A cube is calculated by multiplying A square and matrix A square and A. Already we calculated the matrix A square, that is 1 2 0 1. We are multiplying this matrix with a 1 1 0 1. The resulting the matrix multiplication is that we are multiplying the row of the first matrix with the column of the second matrix. Let us multiply the first row, first column. 1 ones are 1 and 2 zeros are 0. That is 1 plus 0. Next, first row, second column. 1 ones are 1 and 2 ones are 2 plus 2. Next, second row, first column. 0 1 is 0, 1 0 is 0, 0 plus 0. And second row, second column. 0 1 is 0, 1 1 is 1. That is 0 plus 1. And the resulting is what it is? 1 3 0 1. What is matrix A? Matrix A is 1 1 0 1. Matrix B 1 2 0 1. Matrix Matrix A is 1 1 0 1. Matrix A square is 1 2 0 1. Matrix A cube is 1 3 0 1. मैट्रिक्स ए पावर n इज, देखिए पावर 1 है तो 1 है, पावर 2 है तो यहाँ 2 है, बाकी के 3 एलिमेंट सेम है. देखिए पावर 3 के लिए यहाँ 3 है, पावर n के लिए रहेगा 1 n 0 1. दिस इज आवर a power n matrix. So a power n matrix we are identifying from these 4 options. Where is this option? A power n equal to 1 n 0 1. 1 n 0 1 is the last option, D. Last option is D. Directly we can't write that, or we can't find a power n here. Okay, so we are predicting which option is correct by multiplying that by finding a square and a cube. We have a pattern in a square and a cube. The second element in the first row is 1 2 3. As power increasing, the element is changing as the power. पावर 1 है तो वो एलिमेंट 1 है, पावर 2 है वो एलिमेंट 2 है, पावर 3 है एलिमेंट 3 है, तो पावर n है तो फिर वो एलिमेंट भी n रहेगा. सो द आंसर इज 1 n 0 1. Okay, let us move to the next problem. That is third question is we have given a matrix A is equals to lambda 1 minus 1 minus 1. Then for what value of lambda? A square is equal to 0. Matrix A is given and matrix A square is 0 matrix. A square equal to 0 means matrix A square is equal to 0 matrix. Then what is the value of lambda that we have to find? Let us given here A is equal to lambda 1 minus 1 minus lambda, and we are finding A square matrix. A square is A into A, lambda 1 minus 1 minus lambda into lambda 1 minus 1 minus lambda. A square is A into A. And you know the multiplication of the matrices, we are multiplying the row of the first matrix with the column of the second matrix. Let us multiply them. Lambda into lambda is lambda square, and 1 into minus 1 is minus 1. This is first row, first column. Next, first row, second column. Lambda into 1 is lambda. Lambda into 1 is lambda. 1 into minus lambda is minus lambda. Second row, first column. Minus 1 into lambda, minus lambda. Minus lambda into minus 1 is plus lambda. And second row, second column. Minus 1 into 1, minus 1. Minus lambda into minus lambda is plus lambda square. Is given that this is equal to a 0 matrix. Equal to 0 means it is 0 matrix. You can see that here by comparing the first element equal to first element. first element equal to first element, that is we will get lambda square minus 1 equals to 0 and lambda square equal to plus 1, and we'll get a lambda value is equal to plus or minus 1. What is lambda value here? Plus or minus 1. If you compare with the second element, what is lambda minus lambda? 0. 0 equal to 0, that is correct only. The third element of this matrix, lambda minus lambda 0, that is correct only. And the last element is lambda square minus 1 equal to, that is only we have solved here. We got lambda equal to plus or minus 1. If you take any element, any corresponding element of these two matrices, we'll get lambda is equal to plus or minus 1 only. So plus or minus 1 satisfies this equation of the matrices. Okay. And where is this option? This option is second one, lambda equal to plus or minus 1. The correct option is second option. Let us move to the next problem, that is fourth one. We have given a matrix. If a matrix has 24 elements, what are the possible orders it can have? What are the possible orders it can have? How many orders we can write using the 24 elements that we are counting here? Okay, we have a matrix 24 elements. Here given that m into n is equal to 24. You know that 1 into 24 is equal to 24. 24 into 1 is also 24. We are writing all possible orders this matrix has. Okay, so 1 into 24 is also possible. 24 into 1 equal to 24 is also possible. And you know 2 into 12 is 24. And 12 into 2 is equals to 24. So we are writing all possible products which gives a product is equal to 24. So 1 into 24, 24 into 1, 2 into 12, 12 into 2, and 3 into 8 is 24, and 8 into 3 is also 24. And 6 4s are 24, and 4 6 is also 24. Next. Okay. So these are the possible orders it can have. Count them. 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 possible orders. Then our correct answer is 8. Next, we'll move to the next problem. Is given the matrix A is cos alpha minus sin alpha cos alpha, and he has given that A plus A dash matrix is equal to I. I means identity matrix. A dash means transpose of the matrix. A dash is a transpose of the matrix. So resulting the sum of these two matrices is equal to I given, then we are finding the alpha value we are finding. We know that matrix A is a cos alpha minus sin alpha, and sin alpha cos alpha. This is matrix A. And A transpose, A dash matlab A transpose. Transpose of the matrix means we are transferring rows into columns. What is the first row? Cos alpha minus sin alpha. We are writing this as a column. Cos alpha minus sin alpha. Second row we are writing as a second column, that is sin alpha cos alpha. We have changed rows into columns. The resulting is a transpose of the matrix. And later he said that A plus A dash is equal to identity matrix. Let us add A matrix and A dash matrix. Resulting cos alpha plus cos alpha, 2 cos alpha, minus sin alpha plus sin alpha, 0. Sin alpha minus sin alpha, 0. cos alpha plus cos alpha 2 cos alpha, and this resulting is a identity matrix. You know, identity matrix is a diagonal matrix whose diagonal elements are 1, then 1 0 0 1. We have taken this identity matrix. You know, the second element 0 0, third element 0 0, the first element 2 cos alpha equal to 1, or the last element 2 cos alpha equal to 1. So on equating the corresponding element, we'll get 2 cos alpha is equal to 1, or else we'll get cos alpha is equal to 1 by 2. This into 2 I have taken to RHS, it is 1 by 2. And you know, in cos, when we will get 1 by 2 value? For what angle will get this what angle will get cos alpha equal to 1 by 2? Cos 60 degree. Cos 60 degree is 1 by 2. 60 degree in radian, it is written as pi by 3. Then here alpha is equal to pi by 3. The value of alpha is pi by 3, and we are checking for this pi by 3. The second option is correct. Okay students, so like this we are using the concept of matrices and solving the problems. Okay, here we have discussed the 5 questions, and today we have discussed the symmetric matrix, skew symmetric matrix, and the properties of symmetric and skew symmetric matrix, and these 5 problems. So in the next class, we will discuss some more problems based on this matrices. Okay, we'll stop here.